So hello friends, I am Vivek Tiwari, your class instructor for the subject called as Material Science and Metallurgy. And right, till now what we have completed. So what we have completed till now is in the lockdown period we have completed the part of the unit number 2, that is iron carbon phase diagram, its related things, right? We have done everything about that, the invariant reactions, the important phases seen in the iron carbon diagram, the critical temperatures, microstructures of the slowly cooled steels, all those things we have done and completed with the unit number 2. Then we went with the unit number 5 and we started with the discussion about composite materials, its classification, its applications, then how to process basically the composite materials. We have discussed that. Then the polymers and ceramic part, polymers and ceramic parts was also completed by my colleague, that is Professor Prajakta Madam. Then that was the end of your unit number 5. So to say or summarize, we have completed with the unit number 1, we have completed with the unit number 2, we have completed with the unit number 3 also, that is heat treatment. We have discussed about heat treatment, what is the different, what is heat treatment, how do we do it, then what are the different techniques that are involved in the heat treatment process, that is complete heat treatment technique or surface heat treatment techniques. We have discussed about that. And then the unit number 5 also we have discussed. So unit number 1 is done, unit number 2 is done, unit number 3 is done, and unit number 5 is also done. The remaining thing, that is unit number 4, is what I am going to teach in the subsequent 3 classes. This chapter's name is Ferrous and Non Ferrous Materials. Ferrous and Non Ferrous Metals or Materials. Ferrous and Non Ferrous Metals basically. So till now, what you have all discussed or what we have discussed till now, we have discussed about the pure metals. In the first chapter, we had discussed about the pure metals. We had discussed what type of structure pure metal possesses. We had also seen that some kind of defects are inherently present in the metals, and those are called as the metal defects. We have worked out some kind of numericals and all. So basically, first unit was dedicated about the pure metals. The second chapter, if you see, it is about the alloys, that is a mixture of different metals and their phase diagrams. So we went from or moved ahead from pure metals to alloys in the second chapter, and we discussed its properties to be how we learn or how we can understand the properties of alloys with the help of phase diagrams that we had learnt. The third chapter we had moved ahead, and then we had seen how we can change the properties of these alloys, and that is done with the help of a technique called as heat treatment. So basically these 3 chapters, first, second and third, are related to pure metals and alloys, right? And in more particular sense, they were about only ferrous metals. They were basically with about ferrous metals like iron and steel. We were discussing more or less about that only. But it is, if you see the engineering atmosphere, environment around outside, it is not that only ferrous metals are or pure metals or only particular type of alloys that are used for practical applications. Non-ferrous metals are also used for various applications. So that is what we are going to learn in this 4th unit. So we started from pure metal, we moved towards the alloys, we saw how to change the properties of those alloys, and then we are moving towards learning about the non-ferrous metals in the 4th chapter also. And then you should also understand that it is only not that ferrous metals and non-ferrous metals are the one which are very important in engineering scenario. There are other type of materials also. For example, polymers is there, ceramics are there, then composites are there, then smart materials are there, piezoelectric materials are there. These all things we have learnt in the unit number 5. So this is the overall view of your subject, that is material science and metallurgy. To again recapitulate it, we started with the study of the pure metals. We went ahead and learnt about the mixture of metals which is called as alloys. We learnt how to change the properties of this alloys. Then we are learning about the non-ferrous metals, and then we are learning or concluding our discussion about the other type of materials like polymers, ceramics, composites, piezoelectric materials, etc., etc., etc. So this is the overall view of your science of materials, that is material science and metallurgy. So right, so now coming to the unit number 4, that is ferrous, non-ferrous metals and material testing. So here in this chapter, if you see, there are 3 divisions, subdivisions. First one is the ferrous metals and alloys, and second one is the non-ferrous metals or alloys, and third one is the material testing. These are the 3 subdivisions which are there in this chapter. Again, I want to explain you that now onwards, whenever I say metals, I don't mean it as pure metal. Don't take it as pure metal. I am talking about alloys. Why? The reason behind, you know that pure metals is very difficult to process or difficult to maintain and to extract. If we are not in a situation to make or retain a pure metal for our usages, so nobody makes use of pure metal. This I have told several times. So we are all interested in basically alloys. Alloys, why? Because it is easy to make, easy to maintain, and easy to use. So that's why we make use of alloys. And henceforth, when I tell metals, I mean alloys, not pure metal. That's why I have written this here. I have written here like this. Yes. So metals and alloys will be used interchangeably now. So both will be used interchangeably. Anyways, so coming to the chapter, unit number 4, we have 3 subdivisions: ferrous metals. Under ferrous metals, we will be learning about stainless steel and its types. We will be learning about tool steels and its types, and then we will be learning about high strength, low alloy steels, and we will be learning about what are the effect of the alloying elements on the properties of steels. We will be learning about one more important type of ferrous metal called as the cast iron and its various types. Then coming to the non-ferrous metals, we will be learning or concentrating only on 2 non-ferrous metals. One is copper and the other one is aluminium. Only these 2 non-ferrous metals we will be discussing, and again in that we will be discussing about its properties, types and applications in each of these cases. Then we will be learning about the material testing. So here in the material testing, we will be seeing how do the material will behave when it is subjected to different type of loadings, and how to apply those different type of loadings. Basically different type of tests are there. We will be learning about that. So this is the overview of this unit, that is unit number 4, that is non-ferrous, ferrous and engineering of engineering materials and their testing. So coming to the classification of metals or engineering materials. Engineering materials can be classified into various types. You know that we have discussed in the first unit that engineering materials can be classified into metals and alloys. They can be classified as polymers, ceramics, composites, nanomaterials, etc., etc. Coming to the metal part, engineering material, that is metal part, can be further classified into 2 types. One is called as the ferrous metal, and the other one is called as the non-ferrous metal. So what do you mean by ferrous metal? Ferrous metal means one which contains iron in it. The word ferrous only will tell you that. The meaning of the word ferrous is iron. So in Latin, the meaning of the word ferrous is ferrum. Ferrum means iron. So any metal which contains iron in it will be called as the ferrous metal. And the one which will not contain iron in it will be called as non-ferrous metal. And then again in the ferrous metal, it can be classified into 2 types. One is the steel and the other one is cast iron. This basic classification you should all remember for your whole throughout your life. And whenever you go for an interview, they might ask these questions, that materials, engineering materials can be classified into those types, and metals and alloys can be classified into ferrous metals and non-ferrous metals. Ferrous metals can be further classified into steels and cast iron. Now you might be wondering, what is the difference between this steel and cast iron? The difference between steel and cast iron is that one thing is very much common, that both are alloys of iron. That means they contain iron in it. That's why it comes under the category of ferrous metals. But the point that differentiates these 2 type of ferrous metal is the percentage of carbon in it. The percentage of carbon. The percentage of carbon in steel is from 0 to 2%, and in case of cast iron, it is from 2.1 to 6.67%. I will take you this back to the iron carbon diagram. If you remember or recapitulate, recently you have even written the IA. You have seen on the x-axis you had drawn only from 0 to 6.67%. I have seen all of you have drawn the iron carbon diagram, and all of you have written the percentage of carbon starting from 0 to 6.67% only, correct? That is the reason, or that is important point what you should remember, that the percentage of carbon that can go into iron is only maximum to 6.67%, and that's how we differentiate steel and cast iron. Steels are one which contains the percentage of carbon from 0 to 2%, and cast iron are one wherein the percentage of carbon varies from 2.1 to 6.67%. That is the basic important classification you should remember. And under the non-ferrous metal there are copper, aluminum, brass, etc., different type of metals. Under steels there are again different type of steels like stainless steel, which we are going to discuss in today's class, high strength low alloy steel, tool steels which are basically used for making of tools, like that, stainless steel which are used in making of vessels, in making of many of type of pressure vessels, many type of rotating instruments and all. Those are nothing but stainless steels, right? And when it comes to your cast iron, there are different type of cast iron, and examples of cast iron are the manholes which you see on the roads, and even the machine base of a machine, the housings, the motor pumps housing, the motors housings, all those things are made up of cast iron. So with this basic we'll go ahead, right? Again, this is the iron carbon diagram. Most of you have drawn it in the IA, just the previous IA, and you know that on the y-axis we put the temperature, on the x-axis we put the percentage of carbon. And why I am showing you this one is to show you the difference between the steel and the cast iron. So when I had said you just previous slide that the percentage of carbon is from 0 to 2%, I meant this one. That is, when the percentage of carbon is from 0 to 2%, then that part of the ferrous metal will be called as steels. This is called as a steel from 0 to 2%. This percentage of carbon containing ferrous metal will be called as steels. And further again it can be classified as eutectoid steel, hypoeutectoid steel, hypereutectoid steel. We have discussed that in the previous chapter. When the percentage of carbon is from 2 to 6.67%, then it is called as castings or cast iron. Why it is called as cast iron or castings is because this type of metal, the metal which ferrous metal which contains the percentage of carbon from 2 to 6.67%, show a very good fluidity. That means it can melt easily, they can flow easily, they can fill the mold cavity easily inside the sand casting. Okay, so that is the reason why they are also called as cast iron, or some textbooks they call even it as castings. And again it can be again further classified as hypoeutectic, eutectic and hypereutectic steels. This is cast irons. This we have discussed in the last chapter, that is iron carbon phase diagram. So to show you what is steels and cast iron, I have put this slide, and the remaining things and all we have discussed, so I will not go into much detail into it. So that is the thing. Now we will discuss about the term metal. Metal is the one or a component which is lustrous in nature, which shines and which can be formed easily or which can be forged easily. That type of metal is called as metal. Now metal, right, metal was described as one which is bright solid and which can be forged. That sentence what I have written in dark, you can see. A metal was described in the olden days as a component or a material which is bright and which can be forged. Basically forged means it can be shaped, or a particular type of shape could be given to the metal. So in the olden days this was how metal was described, and this definition was given by a Russian scientist called as Michael Vasilonevich Lomonosov. He was the one who described metal as as a component or a metal which possesses two properties. One is which is bright and which can be forged. The meaning of forged is that it can be formed, it can be given a shape. And you know that definition still holds good. Even now also, if I take a metal, in the whole day you can see you make use of so many metals. A metal is one which is very much bright in nature, it will shine, and plus the best property of a metal is that you can give a shape to it. You can form it, you can shape it, and that shape will be retained for a long period of time. That is the advantage of the metal. So that is what I have written in the first sentence. The first scientist definition of the metal was a metal is a bright solid and that can be forged, and still that holds to be true. What are the properties of metal? The properties of metal is that it is lustrous in nature. The meaning of lustrous is that it shines. Then it has the ability for plastic deformation, means you can plastically deform it. Just like a plastic, you can deform it and give a shape, of course at high temperature. Then it also shows very good electrical conductivity and thermal conductivity also. So these are some of the important properties because of which metals are widely used for n number of applications or engineering applications, right? Okay, so now when it comes to metals, metals can be classified as ferrous metals. Ferrous metals means one which contains iron in it, right? And under this ferrous metals, you have again two types. One is steels and the cast iron. Both are alloys of iron and carbon, but however the percentage of carbon is less or more. Here it is lesser from 0 to 2%. Here it is more from 2 to 6%. So that is how it goes. So this slide is like that. Then again, one more way by which you can classify this. So before that we have classified the ferrous metals into two types. One is steel and the other one is cast iron. Now the steels can also be classified further. One way by which we can classify steel is the percentage of carbon. You remember the iron carbon diagram. From 0 to 0.8% of carbon if the steel is having, it is called as hypoeutectoid steel. If the steel contains exactly 0.8, then it is carbon, it's called as eutectoid steel. And if the percentage of carbon is from 0.8 to 2.1, it is called as hypereutectoid steel. This is one way by which you can classify the steel. There are other ways also by which you can classify steel. One more way is the percentage of alloying elements. If the steel contains no other element than iron and carbon, no other element, then that type of steel would be called as plain carbon steel. A steel which contains only iron and carbon, then that type of steel will be called as plain carbon steel. Again, you should remember the percentage of carbon will not be more than 2%. However, if it is having only these two components, iron and carbon, it is called as plain carbon steel. And if it contains some kind of alloying elements, then it is called as alloy steels. Then it is called as alloy steel. Example for alloy steels, can you tell me? Example for alloy steels are nothing but the stainless steel what we see day by day. The stainless steels are used for making of the plates in which we have our food daily. That is an example for stainless steel, and it is basically alloy steel wherein chromium metal is being added to iron and carbon. So like that. So like that we can differentiate steels into further two types. One is plain carbon steel and the other one is called as the alloy steels. And different type of alloy steels I have mentioned on the board. They are for example stainless steel, tool steels, high strength low alloy steel, managing steels, creep resistant steels, low expansion steels, heating element steels, spring steels, valve steels, etc. So what you can see here is that the different type of steels being used for different type of applications. Valve steels are used basically in making of valves which controls the flow of water in the pipeline. Spring steels are basically used in making of spring steels. Then heating element steels are used in the making of heating elements like resistant coils in the furnaces. Then low expansion steels are one which will show low expansion when the heat is supplied to it. Creep resistant steels are one which will not deform even at higher temperature conditions, right? So like that, tool steels are the steels which are used basically for making of tools. Like that, there are different type of alloy steels, and these are some of the examples for those, right? So now in today's class we will discuss about the first type of steel which is very much famous, which is called as the stainless steels, and then we'll go ahead with the tool steels. And then in the next class we will be discussing about the other type of steels like HSLA alloy or HSLA steel, high strength or low alloy steel, right? Like that we are going to discuss. So coming to the stainless steel is an alloy steel, of course, because it is basically alloy of iron and carbon plus chromium should be present into it. That's why it is an alloy steel. High corrosion resistant, it will not corrode. That's why it is called as stainless. It doesn't corrode or rust and does not show any kind of rusting features on it, right? And it is used in the nuclear plants, power plants, pulp and paper industries, food processing units, petrochemical industries. All these industries make use of the stainless steel for making of its components, because in this industry see that high temperature steams are used, water is used, salt waters are used sometimes. These type of components will rust the normal grade of steel. So for that reason, we have to make use of a higher or a better grade of steel, which is called as the stainless steel. So these are the places wherein you will see that stainless steel should be used. Basically, it contains chromium. So stainless steel is one which will basically or surely contain this element, which is chromium. And what happens is that if you have like a component which is made up of iron and carbon with some amount of chromium, the chromium which is there on the upper layer of that component will react with oxygen, forming an oxide which is called as chromium oxide. Metal usually react with oxygen to form an oxide. Here it is called as chromium oxide. That chromium oxide is a protective layer. It will not allow that oxygen to enter into the component inside. It forms a protective layer on the metal component. Even when you scratch it or with a knife or some kind of material, if you try to make a scratch on it, then a fresh layer of chromium will be exposed, and that will again react with the oxygen to form a protective coating. That is the reason why this the component which is having chromium in it will not rust. And that is the reason why it is also sometimes called as a recyclable material. It is not a recyclable material in true sense. However, the thing is that it's recyclable because the oxygen chromium oxide layer which is formed, it forms by itself again and again. That's the reason why it's called as a recyclable material. That what I have written in the red terms. And minimum percentage of chromium should be 13. So if the steel has to be called as stainless steel, then the minimum percentage of chromium should be 13. If it is lesser than 13, then it will be not called as the stainless steel. Then other elements can also be present, like nickel, magnesium, molybdenum, titanium. Other things can also be present, not that it's been restricted only to these three metals, that is iron, carbon and chromium. Other type of elements can be present. These metals will be present for certain specific applications. And there are four types of stainless steel which we are going to discuss now. One is Martensitic stainless steel, Austenitic stainless steel, Ferritic stainless steel, and Precipitation stainless steel. So these are the different type of stainless steel what we are going to learn. Now coming to the first one, that is Martensitic stainless steel. See, when I'm explaining you about the different type of stainless steel like Martensitic stainless steel, Ferritic stainless steel, Austenitic stainless steel, the word for this stainless steel is given as Martensitic because this type of stainless steel, even at room temperature, will show this phase, that is martensite. When I talk about Austenitic stainless steel, at the room temperature, this stainless steel will show the phase austenite. And Ferritic stainless steel means at the room temperature, those type of stainless steel will show the phase ferrite. So that is how the word or the name goes as Martensitic stainless steel, Ferritic stainless steel, and the other one is Austenitic stainless steel. Okay. So now when it comes to the first type of stainless steel, that is Martensitic stainless steel, at room temperature, this type of stainless steel will show the phase martensite. And it is one of the hardest type of stainless steel. So if you want to have application, for an application you are requiring to suggest a stainless steel which is very much hard and corrosion resistant, you should go for this type of steel which is called as Martensitic stainless steel. The basic reason behind it is that at room temperature it will show martensite, and I have explained you previously that any metal which shows the phase martensite will be the hardest, or it will show very good amount of hardness. That's why this is to be used in such situations, right? So steel containing the percentage of carbon from 12 to 18% chromium will be called as Martensitic stainless steel. Okay, and it is the hardest plus it is the cheapest among all the type of stainless steel. This is one more thing you should remember. Stainless steel is usually costlier than steel because you are adding chromium, alloying elements like chromium into it, right? Among the different type of stainless steel, if you want to go for a cheap stainless steel, you can go for Martensitic stainless steel, right? And they are hardenable by heat treatment and they are magnetic in nature. Okay, so they are heat treatable, while other type of stainless steel will not be heat treatable, will not respond to the heat treatment technique. While this type of stainless steel will react or will respond to the heat treatment techniques, and they are magnetic in nature. If you bring an iron, they will get attracted. And where are these type of stainless steel used? They are used in making of razor blades. The razor blades what we make use of, those are made up of Martensitic stainless steel. Even the surgical instruments, the knives and all which are used like this, these are all being made up of Martensitic stainless steel only. Even the ball bearings which are used in the automobile sector are made up of this, that is Martensitic stainless steel. And the very important thing that how you identify this type of stainless steel is by this series, that is 400 series. In industries, if you go, they will not talk or represent this type of stainless steel as Martensitic stainless steel. They will say it as 410 stainless steel or 400 stainless steel. So you should remember that if I am talking about 400 stainless steel, that it means Martensitic stainless steel, or in other words, at room temperature, if you polish it and check its microstructure, you will be seeing the Martensitic phase, which is needle shape in nature, right, with high percentage of carbon in it. So that is what is the all about your Martensitic stainless steel. I have shown you here a turbine blade. This turbine blade is made up of Martensitic stainless steel. Surgical, the razor blade, or this is a knife which is called as a French knife, if I am not wrong. That knife is also made up of Martensitic stainless steel. Surgical instruments, all these things are made up of the type of stainless steel called as Martensitic stainless steel. Now coming to the next type of stainless steel called as the Austenitic stainless steel. This Austenitic stainless steel means what? I have just discussed previously that the word only will tell you the type of phase present at room temperature. Here the phase which is present at room temperature is austenite. Now I have explained you previously when I was explaining you about the iron carbon diagram. I had told you that austenite phase is never seen below the A1 line, that is 723 degrees Celsius. Below that temperature you will never see the phase called as the austenite. Why? Because austenite phase is never stable at room temperature. Then how come in this type of stainless steel austenite phase is present at room temperature? The reason behind is the addition of some kind of alloying elements into it. Apart from chromium, we add some elements like magnesium and nickel into it, and magnesium and nickel are austenite stabilizers. Magnesium and manganese and nickel metal are considered as austenite stabilizers, means they will stabilize or they will make austenite to become more and more stable even at room temperature. So that is the reason why this type of stainless steel will show austenite phase even at room temperature. However, austenite is never stable at room temperature. Why? It becomes stable because of the addition of this type of elements, that is nickel and manganese to it. Here the chromium percent is at least 18%, and along with that manganese and nickel should be there. Then as I said, second line you can read, manganese and nickel are austenite stabilizers and austenite phase is seen at room temperature. That is the reason why they show austenite phase at room temperature. This type of stainless steel are non-magnetic in nature, low thermal conductivity, low thermal coefficient of expansion. The difference between the previous one, Martensitic stainless steel, Austenitic stainless steel, is that Austenitic stainless steel is non-magnetic in nature, while our the one that is the Martensitic stainless steel is magnetic in nature. If I am not wrong, then Austenitic stainless steel, one of the good example is the antenna blades. In the previous days, Doordarshan, what we used to see, in those days there was an antenna. That antenna was whitish in color, and if I am not wrong, that steel is the Austenitic stainless steel. It is non-magnetic in nature. Right? Then it is used for making of utensils, wrist watches, chemical plants, etc. So chemical plants, very much there. This type of stainless steel will be used like this. This type of chemical and parts in the chemical plants. This is being made. One of the important application is the wristwatch. So wristwatch, if you see, should be made up of this type of metal called as austenitic stainless steel, and it is non-magnetic in nature. If it is non-magnetic in nature only, then it is good. Otherwise, you will see that your hand will get attracted to a magnet, right? So that doesn't happen because you make use of a non-magnetic stainless steel called as the austenitic stainless steel, right? Then it is the stainless steel which contains the best possible of all the properties. So if you see the strength wise, it is not that good as that of the previous one, Martensitic stainless steel, but at par to that. And if you see the prices also, it is not as cheap as that of the Martensitic stainless steel, but it is good enough to procure. So all the properties what you want are in optimum manner condition or optimum percentage in this type of stainless steel. And one of the important things is that this type of stainless steel is designated in industries as 300 series. The previous one, 400 series, here it is designated as 300 series. So if they say that it is 316 SS, 310 SS, that means it is an austenitic stainless steel, which means it contains austenite at room temperature. And this is one of the structure which is seen in Australia or some place, which is completely made up of a steel called as austenitic stainless steel, our daily utensils, the wristwatch. These are example of the austenitic stainless steel, right? And again, one more point I have put over here, that it is the most common type of stainless steel which is used, and 70% of the production of stainless steel is this one only. So the highest amount of production of stainless steel is for this one, that is austenitic stainless steel. The kitchen sinks, what we have seen in our houses, an example of this one. Then keyboard springs, the springs what are used inside the keyboards and all are example of this. So here you might have got an experience or an idea about how does this austenitic stainless steel looks like and behaves. It is non-magnetic in nature. Strength is okay, no, but not little inferior to the Martensitic stainless steel. Cheap, also it's good. Rate wise also it's good. So this one. Next, the third type of stainless steel what we have to discuss is the ferritic stainless steel. The meaning of ferritic stainless steel is that at room temperature it will show the phase called as ferrite, and you know that ferrite is very much soft in nature. So a stainless steel which contains ferrite metal, ferrite alloy, ferrite phase will be very much soft in nature, right? So basically ferrite stainless steel are very much soft. It is not that strength wise it is not that as good of our Martensitic stainless steel, but right, that's how the meaning goes. So I have written that ferrite stainless steel, okay. Then steel containing more than 13%. Here you should understand one thing, that here ferritic stainless steels are one which contains a very high amount of chromium into it. If you go on adding chromium to a large extent into the steel, you will end up with a type of stainless steel which is called as ferritic stainless steel. What happens when you add chromium to it to a higher extent? What happens is that it will stabilize our ferrite phase to a larger temperature condition. In the previous type of stainless steel we had discussed, and I had told you that nickel and manganese stabilize the austenite phase. Here the same thing happens, but in the other fashion. You add chromium to a large extent and it will stabilize the ferrite phase, and because of which the room temperature stainless steel will show this phase called as a ferrite, and that's why it's called as ferritic stainless steel. So I have written that stainless steel containing more than 13% chromium up to 27% chromium is the one which gets into this type of steel called as a ferritic stainless steel. Similar to Martensitic stainless steel, however, it is superior. It is superior to the Martensitic stainless steel only in other qualities, but if you see the hardness and strength wise, it is lower, inferior. Expensive and non-heat treatable, and chromium is a ferrite stabilizer and seen at room temperature. Why ferrite is seen at room temperature? It's because of this metal what you have added to it, chromium. Heat exchangers, sugar industries, restaurant equipments, automobile exhaust, etc. are examples. So these are some of the big plants you might have come across. This is an example of ferritic stainless steel. The exhaust tubes which you have seen in many of the vehicles are made up of this type of stainless steel, also designated as 400 series. This is designated as 400 series and it is considered as equal to the Martensitic stainless steel. The difference is that in Martensitic stainless steel you will have martensite, here you have ferrite phase at room temperature. So I have written, now comparing all the stainless steel, I have written about the corrosion resistance and the mechanical strength. If we see the corrosion resistance property, the highest corrosion resistant would be shown by austenitic stainless steel. Next would be by the ferritic, and third one would be the Martensitic stainless steel, corrosion resistant property. And if you check the strength wise, the highest steel, the strength would be shown by the Martensitic stainless steel. The reason is it shows martensite phase. Martensite phase is basically very much hard and strong. The second would be austenite, and the third one will be the ferritic phase. So ferrite phase, you know that it is very much soft in nature. So any metal which contains ferrite phase will be inherently soft. So that's why it is like this. Then coming to the fourth type of stainless steel called as the precipitation stainless steel. So in case of this precipitation stainless steel, the steel will be made up of carbon, iron and chromium. Along with that, some other type of elements like nickel and chromium, nickel and molybdenum, copper, aluminum, such kind of metals also will be present. This type of metals are not usually present. There are special type of metals which are put into the stainless steel, and that type of stainless steel will be called as precipitation stainless steel, because here what happens is that it forms a kind of precipitation or some kind of compound like nickel, aluminum, and settles inside the metal component. Like that one I have said that nickel and aluminum which you have added it to the stainless steel, both will combine and precipitate, or it will form a compound that is nickel aluminum, Ni3A, and that will give specific type of properties to that stainless steel, right? So that is called as precipitation stainless steel, and it maintains temperature at high temperature. So if you want to make use of the stainless steel for high temperature applications, like boilers are there, steam turbines are there, big pressure vessels are there, then tubings are there, wherein heated steam is passing. In those situations, you can probably go for precipitation stainless steel, used for aircrafts, missile industries, etc. Right? So all those things are there, and it is used as a shaft of pumps, valves, etc. So these are the places wherein high temperature applications or high temperature flow is seen, or material of high temperature flows around this metal. So this metal is expected to work at that temperature. For that you can make use of precipitation stainless steel. So till now we have discussed about the 4 types of stainless steels. We have discussed about the Martensitic stainless steel, Austenitic stainless steel, Ferritic stainless steel, and then the precipitation stainless steel. So these are the basically 4 types of stainless steel. Now we'll go ahead with the next type of steel called as a tool steels. Now in many of the situations in your lifetime you will come across one thing, that the name of the thing only will tell you what it means, right? In many of the situations in our life we come across that, and we no need to search the meaning for it. Similarly here also, if you go and understand, if you see this word tool steels, you will understand what are this type of steels. Yes, you are all right. Tool steels are the one which are used for making of tools, basically the tools. So the tools which we have used in our workshops, the tool which we have used in many places for changing the shape of the metals are being made up of this type of steels called as the tool steels. So specially used for cutting, shaping and working of metals, and they should contain this type of elements, that is carbon, magnesium, tungsten, chromium, vanadium, such type of metals it should contain. So the letter C means carbon, Mn means manganese, W means tungsten. The metal called as the tungsten should be present inside the tool steel for making it hard and strong. Vanadium, these are some of the metals or elements which should be present into it to give it a high strength property, right? So again, these tool steels can be further classified into 4 types. One is called as the cold working tool steel, hot working tool steel, then there is something called as high speed steel, and one more thing called as a special purpose tool steels. So these tool steels can be further classified into 4 types. One is called as the cold working tool steel, hot working tool steel, high speed steel, as well as our the final one, special purpose tool steels. I have put some images on the board. So these are some of the different type of tools which are used in workshops, you know that. So these are the different type of drill bits which are used, right? So this is the cutter, a milling cutter. So these are all the different type of, this is a type of gear. So all these things, blade, all these are considered as tools, and these tools should be made up of a type of steel called as a tool steels. Now again, in tool steels there are 4 types. One is hot working, one is cold working, one is high speed steel, and the 4th one is called as the special purpose tool steels. So we will briefly go about discussing about all this type of steels. So when it comes to our, yes, this point shows that this point just come up, which has come up, which means that the tool steels are expected to take a lot amount of loads and withstand sometimes even high temperature. So this is the requirement of a tool steel. A tool steel is expected to take enormous amount of load, cutting load, pressures, plus it should maintain or be stable at high temperatures. So this is what I've put it as a flying this one, right? And then when we discuss about the first type of tool steels, that is the cold working tool steels. Again, I said the word only will tell you what it means. Cold working tool steels means those type of steels which are used in making of tools which has to be used at cold temperature. Cold temperature means what? Room temperature or somewhere near the room temperature. Not more than say for metal like steel, not more than 600 or 500 degrees Celsius or 400 degrees Celsius, not more than that. So if you are making use of a type of steel which is used for making of tools, and that tool is to be used for only room temperature applications, it is this one, that is cold working tool steels. cold working tool steels, right? So used during cold working of the metals, then classified as water hardening steels, oil hardening steels, and hardening steels. So that is the manner by which they are being made, right? So these are some of the examples of the cold working tool steels. In the first year, you have undergone the workshop, basic workshop. There you might have come across this type of hammer, ball-peen hammer. So this ball-peen hammer is made up of this cold tool steel. Then many a times you have seen the gate, our houses, boundaries, compounds are made up of some kind of tools. Those are nothing but like this. The chains, what you can see, all these things are example of the tool steels, and they are basically used for low temperature application. So that's why it's called as cold working tool steels. Then they become soft, warp, and distort. They shouldn't be used for high temperature applications. I've said that it has to be used for low temperature applications, and even though if you make use it for high temperature application, then what will it become? It will warp, it will distort, it will lose its shape. It will be warping, means its shape, if it is straight, it will become bent like this. So all those things will become happen if you make use of this type of steels for high temperature applications. So what is the requirement, or what you should do for high temperature applications? Many situations you come across that you have to change the shape of the metal even at high temperature. Basically at high temperature. For example, forging. You might have an experience. You have heated the metal or a steel, and you need to deform it. You need to change its shape by a tool. That duration, if you make use of cold working tool steel, then the tool only will get warped or distorted. The solution for this one is to make use of another type of tool steel called as the hot working tool steel. Hot working tool steel. So hot working tool steels are like this, right? Used for working of steels at high temperature applications like stamping, upsetting, extruding, piercing, rolling, etc. Those are all hot working conditions. Why you basically heat the metal at high temperature and deform it? Because at high temperature its strength decreases. So at high temperature the steel or the any metal, its strength goes on decreasing, and probably something happens inside. Will not go into detail into much. Its strength decreases and it becomes so easier to deform it, just like a butter. So if you have a butter, you can easily cut it, right? The metal will behave just like that at high temperature application. You can easily deform it, you can easily cut it, and for deforming it, means changing the shape, cutting it, you have to make use of this type of steels, that is hot working tool steel. They do not soften at high temperature applications, and it is also used for making of aluminum dies, magnesium dies, forging dies, etc. So here you can see that this is a billet which is coming out of a steel plant. So that billet has to be changed, that is its cross section has to be varied. For that we should make use of a roller, and that roller has to work at high temperature applications. This roller will be made up of this type of steel, that is hot working tool steel. Similarly, if you see here, forging is being done. This is the component on which a big die is coming and falling intermittently, means after certain duration of time it comes and hits it, because of which the forging happens. In that case also this component will be made up of hot working tool steel. These are again two type of kind of chips or hammer kind of thing, which is again used at high temperature application. You can see this, you have a heated horseshoe, and it is being deformed with the help of a tool, which is hot working tool steel. These are some examples of hot working tool steel. Now other type of tool steels are also there, which is called as, one among them is called as high speed tool steels. So what happens, many of the conditions are of metal working is that you have to work at high speeds. For example, you are rotating a metal at very high speed and then you need to cut it. At that duration of time, the amount of strength, the amount of load which acts on the tool is completely different, and to sustain that different type of temperature and loadings, we have a special grade of steel called as the high speed steel. So that is what it means, high speed steel. Basically it is used for making of tools only. So maintains its hardness even till to 550 degrees Celsius, and hence used for cutting of metals at high speed. Basically when you are working at high speed conditions, you make use of this type of steels called as the high speed steels. And there are again two types, that is tungsten and molybdenum steels. There are again two types, tungsten means which will contain tungsten, molybdenum means which contains molybdenum. Then other type of tool steels are also there. The last one, the steels which are not classified as cold working tool steels, not as hot working tool steels, not as high speed steels, then they will be classified as special grade of tool steels. Okay, they will be classified or considered as special purpose tool steels. So the remaining steels used as tools are grouped under this group, and shock resistant tools, low alloy tool steels, mold steels, etc. are examples for this, and they are used basically for cutting purposes. For example, you have a type of tool called as a Cermat. That type of tool will be coming under this, which is called as a special type of special purpose tool steels. That Cermat is made up of two things, one is ceramics and the other one is metal. So ceramic plus metal together, it is called as Cermat. It is called as Cermat. Similarly, there are other type of tool steels or tools called as stellites. All these things are used for cutting of metals, and they are coming under this special purpose of tool steels. Okay. So these are the different type of tool steels what we have to discuss. So in today's class, what we have discussed is about only the ferrous metals. Again, there will be a class about non-ferrous metals. Only in the ferrous metals we have seen that ferrous metals can be classified into steels and cast iron. Again, we have seen that the steels can be classified as different type of steels, that is stainless steel, maraging steels, valve steels, then creep resistant steel, high temperature steels, and etc. etc. So we took discussion only about the stainless steel, and under stainless steel we saw there are different types, that is Martensitic stainless steel, Austenitic stainless steel, Ferritic stainless steel, then Precipitation stainless steel. And again, we discussed about one more type of steel called as a tool steels, which are basically used for making of tools, So this is what we have discussed in today's class. In tomorrow's class, or in the next discussion, we will be discussing about another type of steel which is called as HSLA, that is high strength low alloy steel. So I will be discussing about that in the next unit, the next chapter. Okay. So coming to your this one, that is IA, we are evaluating your IA, and we are doing it, and in a day or two we will be telling you about the results. However, the discussion about the IA questions were very simple. They were from the unit number 2, that is the iron carbon diagram. The question was to draw the iron carbon diagram. Most of you have drawn it. One more question was to write the invariant reactions seen in the iron carbon diagram. That also many of you have done it very nicely. Then in this chapter there was a question about the creep curve, which you all have done nicely. Then other related questions. Then the quiz question has also been answered. Everybody has answered it rightly. So more or less the performance is good. So if you want, I will discuss it about the question paper in the next classes. But before that, we will try to finish off this unit so that it helps you in the examination. So with this, I would like to stop down my discussion at this point. So next discussion will start with the HSLA, that is high strength low alloy steel, and then the remaining portion of the unit number 4. Okay, thank you.